Hi, I'm Renjilal. Today we have a new chapter in 10th standard. Its name is Electricity. This chapter is followed by CBSE. Before we start the chapter, we have some basic idea which we studied in the earlier classes. Okay, some introductions about the chapter. Electric charge. We already know there are two types of charges, positive and negative charges. Okay, so positive and negative charge we already know that. So how will you explain or how will you determine the positive charge is there and a negative charge is there? Let us discuss. We know there are the charge of electron is negative. The charge of electron is negative, and the charge of holes or proton is positive. Okay, then we have some charges in the system. Here is a system or atom or anywhere. So we take a system here. So in this system there are 10 electrons are there. We already know that the charge of electron is negative, means 10 electrons means 10 negative charges there. Again, from this system, a negative charge of electron is lost. So there is a negative deficiency of electrons is there. So instead of this, we have a positive charge is there. Positive charge is there. Means deficiency of electron in a system or anywhere is known as a positive charge. Okay. The opposite, we have 10 electrons are there. When 10 electrons here there, and then an additional electrons are added to the system. Added to the systems. So, which means a negative excess of negative charge is added to the systems. So that is known as sufficiency of electrons. Clear? So positive charge means in there as in a system or in atoms or where a deficiency of electrons is occur, that is known as that is known as where a positive charge is occur. Instead of negative charge, a sufficiency of electrons occur, means an additional negative charge or excess of negative charges occur in a system that is known as negative charge. Okay, so we know positive and negative charge how they occur. Then next we studied like charges repels and unlike charges attract. So what is like charges? A positive charge is there and a positive charge. Positive will attract or repel. It will repel. This means this positive and positives are same charges or like charges. So they repels. And similar way, a negative and negative charges is there. Same charges means it means like charges is there. So in these conditions also repel. The charges are repels. But in the case of a positive and a negative charge, it's an unlike charges, isn't it? So in this condition, what will happen? Attract. And also negative and positive, same way. It is also different or unlike charges. So it will also attract. Okay? In this case, same charges or like charges is there. So it is repel, and unlike charges is there. Okay? So it is attract. And charge of electron is the SI unit of charge is coulomb. Means SI unit of, you know, the SI unit of distance is meter, and likewise, okay, meter, kilogram, second, like. And likewise, SI unit of charge is coulomb. It's denoted as capital letter C, capital letter C. And next point we discussed in the last class, charge of electron is negative 1.6 into 10 raised to 19 coulomb. You must study this, which will help to solve the problems. Okay, the charge of electron is minus 1.6 into 10 raised to minus 19 coulombs. Is minus or negative sign is important because charge of electron is negative. So we put the negative instead of these parameters. 1.6 into 10 raised to minus 1.6 into 10 raised to minus 19 coulomb. And charge of proton is plus is there. We have sometimes this positive charge is not taken in this parameter. Okay, so plus 1.6 into 10 raised to minus 19 coulomb or 1.6 into 10 raised to minus 19 coulomb is the charge of proton. Okay, and next one is mass of electrons. Mass of electron is 9.10 into 10 raised to minus 31 kilogram. Okay, and mass of proton is 1.67 into 10 raised to minus 27 kilogram. At least these points we must study for this chapter, for help to this chapter. Next is electric current or intensity of electric current. So we represent the symbol capital letter I, intensity of electric current. So I is represented for electric current. So what are the parameters we studied in this chapter for in the case of electric current? So first, the flow of electric charge is electric current. The flow of electric charge is electric current. Suppose here some electric charges are there. Some electric charges are there. Okay, these electric charges is moving from A. This is A and B is the position. The electric charge is moving from A to B or A to B. So where an electric charge is flow from a particular position to another position, there will be an electric current is occur. Okay, so the flow of electric charge, this flow of electric charge is known as electric current. Clear? More specifically, we discussed in the we studied in an exact definition. What is this? Electric current is the amount of electric charge flowing through a particular area of conductor in unit time or 1 second. We take unit time means 1 second. Suppose in a particular area, the first point is also correct. So more specifically we discuss in this definition. Suppose the area, this is a unit area. This is a unit area. Then the inside a unit area, the electric charge, A position is there and B position is there. Okay, and electric current, electric charge is there. Some electric charge is there. This electric charge is flowing from this to the flowing through the unit area, the particular area, Here unit area. Okay, we take unit area. Unit area means length, breadth, height, all are 1 meter or 1 centimeter of unity. Okay, so in particular unit area, these charges are moving or flowing through this. In a unit time, how much amount of electric charge are flowing through that particular unit area? That is known as electric current. It's nothing but it's a unit area some electric charge is moving through this electric unit area. Okay, and how many electrons are flowing through this particular area in 1 second, that is known as electric current. Okay, more specifically. Okay, this is the second definition. Clear? More specifically. Okay, then through this definition we must take a formula. Okay, which formula? We already know the electric current is represented as capital letter I because of intensity of electric current. So I, capital letter I. So the earlier slide we have Q is the electric charge, and already know time is represented as a small letter t. So in a particular time, how many electric charge is moving? That means Q by T. Okay, Q by T means electric current is I is equal to Q by T. Okay, Q by T. Q is the electric charge, T is the time taken, and I is the electric current. Okay, the unit of electric current is ampere. Okay, derived unit is what is derived unit of electric current? So charge, electric charge of Coulomb, and time is second. Coulomb per second is the derived unit of electric current. But the SI unit of electric current is ampere. Again, is letter, a capital letter is used for representing ampere. Plus 1 ampere means how much? 1 ampere of electric current means 1 coulomb of charge in 1 second. 1 by 1 is equal to 1 ampere. Okay, 1 ampere. One in a system or in a circuit, 1 ampere is present, which means 1 coulomb of charge is present in 1 second in that circuit. Clear? And the electric current is the rate of flow of charge. Another definitions means rate of flow of charge means in a particular rate. Rate of flow of charge means in a particular time, in a particular charge is moving. That means the electric current is the rate of flow of charge. Another definition. Okay, 1, 2, and 3 definitions are already discussed. Another definitions depends upon this formula. Through any formula in physics or any formula, we derived, we state the definitions. How? The above numerator is taken before ratio. Okay, means electric current is the ratio of electric charge. This electric charge is in numerator, and after 2 the electric time taken t. Okay, so electric current is the ratio of electric charge to the time taken for flowing that charge. Okay, we note 2 and ratio. Okay, electric current is the ratio of electric charge to the electric time taken for flowing that charge. Clear? Another definition. How many definitions are there? 1, 2, 3, 4. Okay, this is the exact correct definition. Okay, second one, and our third one is also followed. Next, the device is used to measure electric current is ammeter. That measure to the, so in a circuit how many current is there. Okay, humidity column is there. We did not detect a device is known as ammeter. This ammeter is also present in your home. Okay, so a meter reading is there. Clear? So ammeter is there. And ammeter is always connected in series. Series connections, parallel connections is there. Okay, series connections means a bulb is there. Okay, a resistor. Okay, already discussed this in the next slide. Okay, series connection. This is known as resistance to resistance. This is series connection. And parallel connections means this. This is parallel. Okay, parallel connection. Okay, so in an ammeter is always connected in a circuit in series. Clear? Next is electric potential difference or voltage. Voltage. So we denote it as capital letter V. Okay, electric potential difference or voltage. What do you mean by potential difference? We have a simple example. Suppose a stone is there. Stone is here. Okay, in a point, we need to move the stone to B. So we need to move the stone from A to B. We must do a work. Okay, so we work from A to B. We work some work, or we have to done a work or work done to move this stone to travel from A to B. Okay, so that work done is known as potential difference. Okay, potential difference, which means potential difference between 2 points is defined as the work done to move a unit charge from one point to another. Okay, instead of this stone, we put some electric charge. Electric charge is there. Here some electric charge is there. From in a point, we need to move from A to B. When a electric charge is moving from A to one point to another point, which means here A to B, we get an electric current. Okay, instead of moving the electric charge, we must do a work. Okay, that work done is known as, it is the potential difference between that point. Okay, the potential difference between 2 points, any 2 points, here A and B, any 2 points is defined as the work done, how much work done to move, a unit charge. To move a unit charge, how much work done to move a unit charge. Unit charge means one charge. Okay, unit one charge. One or unit charge. Okay, one charge. Unit charge from one point to another. Okay, from here A to B, a unit charge is there situated in A. We have to move from A to B. Okay, from A to B, that to move that charge we need some work. Okay, that particular work is known as electric potential difference. The potential difference between 2 points is defined as the work done to move a unit charge from one point to another. Clear? Next is the definition, the formula. Potential difference means electric potential difference is denoted as V. Potential difference is denoted as V. V is equal to W by Q. W is work done and Q is the electric charge. Okay, how much electric charge they need, how much electric charge is there, instead of this electric charge they need to move, have some work done. Okay, that is known as electric potential difference. So V is equal to W by Q. W is the work done and Q is the electric charge. Clear? And the derived unit of a potential, electric potential difference is, what is the unit of, as a unit of work done? Joule. It is an energy. And electric charge, just before we studied, it is coulomb. Joule per coulomb is the derived unit of electric potential difference. But the SI unit of electric potential difference is volt. Again, denoted as V. Small v and capital V also used. Clear? And the device is used to measure electric potential difference is voltmeter. What is electric potential difference is denoter or device to denote or to measure the electric potential difference is voltmeter, where in the case of electric current ammeter, here electric potential difference, so it is voltmeter. Next, the voltmeter is connected in parallel. Voltmeter is connected in parallel. While in the case of ammeter, the current to measure the current, it is in series. Okay, voltmeter is connected in parallel. Ammeter is always is connected in series. We must note that. Okay, this much about electric potential difference or voltage, and another point, another terms or content is also there. Electric circuit. Okay, electric circuit. What do you mean by electric circuit? A continuous and closed path of an electric current is called an electric circuit. Okay, suppose here we already studied the open circuit and closed circuit in the previous classes. Okay, so circuit, we already know that circuit is, what do you mean by circuit? Okay, this is open circuit, which is there is no connection. So it is open circuit and this is closed circuit. Okay, the continuous and closed path, this is a closed path. Okay, continuous, here continuous and this continuous movement of this. Okay, continuous and closed path of an electric current. This is a closed path. Instead of this closed path, a continuous electric current is moving. Continuously electric current is moving. That is known as that particular figure is known as electric circuit. Instead of electric circuit, there are so many devices is there. We discuss in the next slide. Next is electric symbols. Some basic electric symbols are we discuss in this syllabus. Okay, so first symbol is electric cell. How to represent an electric cell in a electric circuit? A larger line and a shorter line, and these larger lines is represented as positive terminal of the cell, and the smaller line is represented as the negative terminal of the electric cell. Okay, the battery, larger line and smaller line, larger line, smaller line, larger line, smaller line, likewise, which means many cells together to form a battery. Many cells. So a single cell is there, a single cell is there. The single cell and single cell, much more the single cells are together, we call it as a battery. Okay, which is when it is 3, 4, 5, 6, 7, etc. Electric cells are together to form a battery. Next is switch. Open switch and closed switch. Open switch, here is there, and open, which means there is no connection. There is no connection between this. This is open switch. And closed switch. Closed switch. The line is closed. Line is touching on this terminal. Okay, this is closed switch. This is open switch and this is closed switch. Which means this open switch, in the case of open switch, the circuit is off. And in the case of closed switch, the circuit is on. Which means the terminal is connected. The circuit is closed. Okay, next is connecting wires. Connecting wires. So there are two types of connecting wires. Is there connected wires and non-connected wires? So how will you how will you know a wire is connected or not? This is one wire and simply touching on that wire, which means this these two wire is connected. If there is no connections in between a wire, we represent this is one wire and here and this is non-connected, or there is no connection between these two wires. This is known as not connected wires. Okay, next is electric bulb. How will you represent an electric bulb? This there and this. Okay, this is electric bulb. If it is glow, the electric bulb is glow, some lines this. Okay, if it is not glow, okay, when the switch is open, there is no glow. Okay, so then this is not okay. Okay, next is resistor. Resistor means here this is the representation or the symbol of resistor. Variable resistor or rheostat. Variable resistance or rheostat. Variable resistance is also known as rheostat. How will you represent variable resistor? This and what is the resistor and variable resistance, the difference? So we can adjust the resistance. We can adjust the resistance, which means the line is connecting here, the resistance is low. When the line is connected this point, the resistor is high. Okay, which means the adjustable resistor. It is a adjustable resistor. So we call it as variable resistance, or it is known as rheostat. The symbol of rheostat or variable resistance is this. Next is ammeter. Already discussed ammeter. Simply A. This is known as ammeter. And the case of voltmeter, simply V. This is voltmeter. Voltmeter. An inductor. Inductor is there. This is the representation of an inductor. So many representations, so many symbols are there. So this is a basic, some basic electric symbols are there. So what is the purpose of electric symbol? So suppose a bulb is there. Bulb, electric bulb. We draw in order to draw in a bulb. So like this wise, okay, and no, likewise, okay. In order to represent this bulb, so many space we need. So we use electric symbols. Okay, electric symbol instead of the original diagram, original figure, right? Next is an important law is Ohm's law. Okay, there is no pronunciation this H. It is a very important law. Whenever you study in physics in the earlier classes, this law is, you must study these laws. Okay. So what is an Ohm's law? Suppose a figure is there, an electrical circuit or electrical diagram is there. So instead of this the earlier slides, we study some symbols of the electrical symbols. Okay, these electrical symbols are connected and to go together with each other, we get an electrical circuit or an electrical diagram. Clear? This is an electrical diagram. So what is in this electrical diagram, what are the electrical symbols are there? This resistor is there, a voltmeter is connected in parallel, and a ammeter is connected in series, and a closed switch is there, or an open switch or no closed switch. In the initial condition it is open switch, so the open switch. Okay, and some batteries are battery. Okay, battery is there. So when you connected or switch closed circuit, when you connected or when the switch is opened, there is no connection. When the switch is closed, the circuit is connected, and there is the electrical current flows. Okay, when opens the closed switch, the circuit is closed. So the electrical current goes through this, and a reading is in the voltmeter. A reading where how much voltage or volt is there, and we denote it. It is a device to know the voltage. And also in ammeter, the current in the circuit, the current is how many current is there. Okay, how many current is there, which we denote in the in the case of the ammeter. Clear? So suppose in a particular time, we have a voltage V1. On that particular time, ammeter read the current I1. Okay, and also in the case of second case V2, another time, and in those time the current is I2, and V3 is the next moment, and the current is I3. So it goes on, and when Vn is there, voltage is Vn, and current is In. Okay, so some moments the current and voltage is there. So here V1 by I1, okay, we divide each other, and V2 by I2 and V3 by I3, etc. Vn by In all are equal, all are constant, which means V1 by I1 is equal to V2 by I2 is equal to V3 by I3 is equal to, when V4 by I4 is there, okay, etc. Vn by In is equal, all are equal, or all are equal and I is equal to a constant. Okay, so in generally V by I is equal to a constant. Okay, from this we have V by I is equal to a constant. Okay, V by I is equal to a constant. We remove the n, two n's. Okay, V by I is equal to a constant. Okay, instead of any moment, V and I denoted in the first case V1, V2, V3, V4 is present denoted in the voltmeter. I1, I2, I3, I4, etc. is denoted in the ammeter. Okay, all readings are put together here. We get a constants. Clear? So instead of these equations, we have V is equal to a constant into, taking the left side, into I. This is the first equation. I take this is the first equation. V is equal to constant into I. Okay. We remove the constant and which means these equalities changes into proportionality. We remove the constants. Okay, and also in the case of we added a constant instead of a proportionality, we change the equality symbols. So in order to change the equality to a proportionality, V proportional is equal, V is proportional to I. We remove the constant. Okay, here second equation. Okay, this second equation is the statement of Ohm's law. What is Ohm's law? At constant temperature, temperature in this circuit, temperature is constant. Okay, imagine this. At constant temperature, the electric current flowing through a conductor. The electric current is flowing through this conductor. Okay, always flows when it's closed. The switch is closed. Okay, the electric current flowing through a conductor is directly proportional to. Electric current or I is proportional to V. Same. Okay. An electric current flowing through the conductor is directly proportional to electric potential difference. Electric potential difference or voltage or V is there. Okay, between the ends of the conductor. Okay, this is a statement. From these equations or from this formula, okay, we say that at a constant temperature, the electric current flowing through a conductor is directly proportional to the electric potential difference between the ends of the conductor. Clear? Okay. From this first equation, the first equation, V is equal to constant into I. This is a constant. So V, instead of this constant, I write a symbol R into I. I. This R is known as resistor. We already studied that resistor, the symbol of the resistor. Okay, those resistor, those symbol is denoted as a symbolic representative of letter R. Okay, resistor, which means V is equal to R into I or IR. V is equal to IR. Important formula. Okay, Ohm's law, V is equal to IR. Clear? This is the third formula. From this V is equal to IR, what is the, from this equation, what is I? I is there. This R is taken in the left side, so I is equal to V by I. Okay, this is the fourth formula. Clear? And V by R is equal to V by I. Okay, so in the case of I, what will be V by R? Okay, from this third formula, R is there and I taken the left side, so we get the R is equal to V by I. And in the case of I taken the right side and R is taken the left side. Okay, this is the fifth formula. All these formulas, V is equal to IR, R is equal to V by I is equal to V by R, all we study because of these formulas is used to find the problems. Okay, so from this Ohm's law, the graphical representation also we draw. A graphical representation. Okay, suppose the graph, voltage is taken in the x-axis, and in the case of y-axis, we take the current. Okay, and we get from this graph a straight line. V and I, which means V by I is equal to constant. So all the constants, suppose imagine V by I is equal to 2. Imagine all the points are connected in 2 like this, likewise. Okay, clear? So here we get a straight line graph. Okay, this is the graphical representation of an Ohm's law. Now we start this class today. We will see you soon. Thank you.